In this video, we're going to discuss the domain of a rational function. So recall that domain is the set of inputs for a function, things you can plug in. And when dealing with an expression, it's just like, what x's am I allowed to plug in? And what does that mean, allowed? For instance, we've had the square root of x before. I could not plug in -3 because I can't take the square root of -3 and get a real number. So -3 would not be in the domain of the square root of x. So that's what I mean by allowed to plug in. Certain things have certain rules that you have to make sure you follow. All right, so the base case, the most kind of simple rational we can deal with is 1 over x. So what can I plug in? Well, can I plug in 2? Well, that'd give me 1 over 2. That's fine. 1 over 2 is a number. Can I plug in like 10? 1 over 10 is fine. Can I plug in a negative number? 1 over -2? That's just -1/2. That's fine. So it seems like you can pretty much plug in anything. But a little bit ago we learned whenever you're dividing, there's one number that doesn't make sense to divide by. And the number we can't divide by is 0. So if we ever get in a situation where we're dividing by 0 that doesn't make sense, so all of like the values are going to make sense except for one single value we can't divide by, and that's x. So how are we going to write this? All right, we're going to get kind of fancy. We're going to write our domain like this. Our domain is, all right, we use these squiggly brackets because that represents like a set of things. It's not like a one single answer. All right, so how can we say that everything works? Well, for that we have all real numbers. And mathematicians hate writing words, especially 3 words in a row. That's insane. So we're just going to replace this with a symbol. So what you're going to do is you're going to write an R for real numbers. But to make it fancy and represent this, not just like an R, this is a special thing representing all real numbers, we put this double bar on the back. So everything works. But not everything works. There's one thing that doesn't work. So what we're going to do is put a little comma and say, well, everything but this one thing that doesn't work, the one thing that doesn't work is x can't be 0. All right, so this is the way the domain of your rational is going to look a lot. Squiggly brackets representing it's a set of a lot of things. R, this double line R means all real numbers, so everything works, but we have to take out a value or maybe 2. All right, so we can plug in pretty much anything but 0. All right, so if we make it a little bit more complicated, x over x plus 7. All right, well, again, in this case, I can plug in 0. If I plugged in 0, I get 0 over 0 plus 7. That's 0 over 7. And it's fine for 0 to be on top of a fraction. That gives me 0. So this says I can plug in 0. So it's not always 0, but it is the thing that would take the bottom of my fraction and make that 0. So if the whole bottom of my fraction is 0, that's a bad thing. So when we're doing these rationals, we think about the bad values. Because there's a lot of good values. Pretty much everything's a good value. But the bad values are when the bottom of your fraction is equal to 0. In this case, fairly simple to solve. Subtract 7. So what is my domain going to be? We're going to write it the same way as our last one, squiggly bracket, all real numbers, but I can't be that one bad value. So I can plug in anything but -7. Again, why is -7 bad? Because if I try to plug in -7, I get -7 over -7 plus 7, which is -7 over 0, and -7 over 0 you can't do. Right, because you can't divide by 0. All right, so when you're finding the domain of a rational, you're going to set the denominator equal to 0. Right, we actually don't care what the numerator be. The numerator can be whatever. It can be 0, 1, a million. Set the denominator equal to 0, solve the equation. That's going to give all of the bad values. So my domain is all real numbers but those bad ones. All right, so now things are going to get a little bit more complicated, only in the sense that the expression on the bottom could be pretty much anything, but in this case, we're trying to find the domain. We're going to find the bad stuff. The bad stuff is whenever the bottom of the fraction, the whole bottom of the fraction, would be equal to 0. Like I said, this was all 0, I'd get something over 0, and that's bad. So now the question is just, okay, how do I solve this equation? We have 2 main ways. Right, option 1, it's a quadratic because there's an x squared, so you can do the quadratic formula. And option 2, you can break this down into smaller pieces and factor it. Right. And again, this is entirely up to you. Both options are good options, all right, and they're kind of interchangeable most of the time. Again, I put quadratic formula first because it always works. Factoring doesn't always work, but when it does, I feel it's less steps and less tedious. So I'm going to try to factor. That means I would have to add to -1 and multiply to -12. That's -4 and 3. So now my equation is 6x squared minus 4x plus 3x minus 2. Factor by grouping. And break up into my two factors. And, you know, a lot of the times you always ask, like, why do we care about this math thing? Why do we care about factoring? One of the reasons we care about factoring is because we can break this more complicated expression up into two smaller pieces. And as long as they're equal to 0, now I can take these smaller pieces and set each of those pieces equal to 0. So it allows me to take a complex equation and break it up into two, but much simpler equations. In this case, I add 2, divide by 3. In this case, I subtract 1, divide by 2. And you did all this work. Make sure you actually answer the final question. A lot of students will stop here because they know what they're supposed to be doing. They've found these values. But remember, we're asked what is the domain of this function. So the domain, it's always going to look the same for these rational functions. It's all real numbers. But I have to take out the bad values. X can't be 2/3. And you can write another x can't be -1/2, or you can just kind of put these one after the other. And again, like writing the least amount as possible. So x can't be 2/3 or -1/2. All right, another example, again, same thing. Think about it for a second. We want to find the bad values for our rational. The bad values are when the bottom is 0. This one, we have a third method that we couldn't use in this example because that middle term, but there is a third method you could use. You could use the quadratic formula, you could factor, you could also use square roots for this one. All right, but I'm still going to factor because this one factors pretty nicely. It's a difference of squares. 2x minus 5 times 2x plus 5. Break it up into two separate pieces. Add 5. Divide by 2. Subtract 5. Divide by 2. And again, don't forget to complete the problem. The domain is, every real number, but x can't be positive or negative 5/2. All right, and again, there's no problems listing these out as two separate ones, but I know all the tricks to write the least amount as possible. Okay, this one says example, but this one is your turn. Go ahead and try this one on your own. All right, find the domain of this problem. I'll show you the answer in 3, 2, 1. And so you're going to set the bottom equal to 0. You're going to figure out the bad values using your little shortcut factoring method, or 6 and -4. And again, our domain, everything works but -4 and 6. So I could plug in 0 into this, I'd get -5 or -4. I could plug in 1, but if I were to plug in -4, this bottom would be 0, and that's bad. All right, so remember, dividing by 0 is really the only thing you're concerned about when your function is a fraction. All right, so you want to set the denominator equal to 0. That's going to give you the bad values, and your domain is everything but those bad ones.